On this F150 with the 2.7 EcoBoost, P0138 means the PCM is seeing an overvoltage condition on the bank 1 downstream heated oxygen sensor circuit. In plain terms, the rear oxygen sensor signal may be staying higher than expected. The truck may turn on the check engine light, and depending on what is actually wrong, it can involve the sensor circuit, wiring or connector problems, exhaust leaks, unmetered air, fuel selection concerns, or the sensor itself. Start with the basic system checks, and if other codes are present, check what they mean first. For this episode, we're following the path for P0138. First, confirm P0138 is present. If it is not present, do not force this path. Move back to symptom-based direction. With the ignition off, inspect the HO2S harness and connectors. Make sure the oxygen sensor connectors are on the correct engine bank. Look closely at the HO2S connectors, PCM connectors, and inline connectors for cross-sensor wires, loose or incorrect connections, damaged or spread pins, pinched wiring, shorts, corrosion, oil or water contamination, and sensor damage. If you find a clear concern, repair it as needed, clear the PCM codes, and repeat the self-test. If that inspection is clean, continue with the P0138 path. Next, check for unmetered air leaks, because fuel calculations can be affected by air entering where it should not. Inspect the hoses at the MAF sensor assembly, the hoses at the throttle body, the intake manifold gasket area, the PCV system, disconnected vacuum lines, and make sure the engine oil dipstick tube, and oil fill cap are seated correctly. If you find an air leak, repair the source of the leak, reset KAM, and repeat the self-test. If there are no air leaks, keep moving. Now, check the exhaust system. Regulate shop air to 34.4 kPa, 5 psi, before connecting it to the system, and do not exceed the damage limit. Pressure above 241 kPa, 35 psi, can damage components. Pressurize the exhaust at the exhaust pipe outlet, then use a soap and water solution to check for leaks. Work the exhaust flanges and gaskets, the upstream oxygen sensor and mounting surface, the exhaust section between the upstream and downstream sensors, the downstream sensor and mounting surface, and the exhaust system within 15.25 centimeters, 6 inches, of the downstream sensor and mounting surface. Also check the exhaust flange bolts and the downstream HO2S for correct torque. If you find an exhaust concern, repair as needed. Run the HO2S and catalyst monitor drive cycle procedures. Clear the PCM codes and repeat the self-test. If the exhaust checks clean, continue. Before going into circuit testing, verify with the customer that flex fuel is not being used in a non-flex fuel vehicle. If there is a fuel selection concern, correct it as needed, clear the PCM codes, and repeat the self-test. If there is no concern there, move on to watching the sensor data. Start the engine and let it idle until the HO2S heater PID shows on for 2 minutes. Then monitor the correct heater PID and oxygen sensor voltage PID for the sensor being tested and record the voltage. For the bank 1 downstream sensor path, that means watching the HTR12 PID and the O2S12V PID. All PIDs may not be available on all vehicles. If the PID voltage is between 0.6V and 1.0V, go to a wiggle test. If it is not in that range, move to the circuit open check. If the sensor voltage looked normal at idle, keep monitoring the heater PID and oxygen sensor voltage PID. Then do a thorough wiggle test on the HO2S harness. You are looking for the signal to react while the harness is moved. If the voltage changes during the wiggle test and the value goes greater than 1.1 volts or less than 0.6 volts, repair the wiring concern as needed. Clear the PCM codes and repeat the self-test. If the wiggle test does not show that change, continue to circuit testing. With the ignition off, disconnect the PCM connector and the HO2S12 connector. Check both halves of the HO2S connector for water contamination. On the 2.7-liter EcoBoost, measure resistance between C142 pin 3 and C1232T pin 12, and between C142 pin 4 and C1232T pin 27. If the resistances are less than 5 ohms, continue to the short circuit check. If they are not less than 5 ohms, repair the open circuit, clear the PCM codes, and repeat the self-test. Next, check the HO2S circuits for a short. For the HO2S12 circuit on this engine path, measure resistance between the listed C142 pins for the sensor circuits. The decision point is simple. If the resistances are greater than 10K ohms, move on to the short-to-voltage check. If they are not greater than 10K ohms, repair the short circuit, clear the PCM codes, and repeat the self-test. One measurement row in this part of the circuit check is unclear. If the exact matching test point is not clear at the vehicle, pause, recheck the earlier diagnostic path, and avoid guessing. Then, check the HO2S circuit for a short to voltage. Turn the ignition on and measure voltage at C142 pin 4, as shown for the HO2S12 circuit. If any voltage is present, repair the short circuit, clear the PCM codes, and repeat the self-test. If no voltage is present, continue to the final connector and operation check. The return point for this voltage measurement is not clearly shown here, so do not invent one. If the test setup is unclear, pause, recheck the earlier diagnostic path, and avoid guessing. For the final operation check, turn the ignition off, disconnect all PCM connectors, and disconnect the HO2S12 and HO2S22 connectors. Inspect for pushed-out pins and corrosion. Then reconnect the PCM connectors and both HO2S connectors, making sure every connector is fully seated. Reset cam and verify whether the concern is still present. If it is still present, install a new HO2S in question, reset cam, and repeat the self-test. If the concern is gone, the system is operating correctly at this time, and the issue may have been caused by a loose or corroded connector. Keep verification separate from testing. After any repair, clear the PCM codes, reset KAM where the path calls for it, run the required monitor or self-test steps, and confirm P0138 stays gone. The takeaway is to prove the basics first, then prove the sensor signal and circuit integrity before condemning the sensor. For more diagnostic training, visit stepdiagnostics.com.